Unfortunately, though, that's a terrible way to start a video. Unfortunately, though, when we have to deal with adding and subtracting with fractions, we have to have a common denominator. And sometimes that can take a little while to build. Now, sometimes we're going to get fortunate like we do up here at the top in part 1, where the denominators are going to be the same already. We wish that was the case all the time, but it's not. So if my denominators are the same, I leave them alone. So they're both 3x, leave that alone. And then I just follow the operation up in my numerator. 4 plus 5 is 9. But before I circle it, notice I don't have any strong bonds. I don't see any pluses or minuses here. So in this case, I can reduce the 9 and the 3. They're each divisible by 3. And you're like, well, wait a minute, why isn't it 3x? Because remember, okay, let's do a quick rewind here. Were we okay here? Because I just added up what's on top, I left the bottom alone. But what's 9 divided by 3? 3, and since the 9 is my larger value, that's where my 3 goes. The x doesn't move. Okay, the x is down in the denominator. It's fine being down there. I just have to be careful where I put the 3 in this case. Now that actually is my answer then. Okay, so sometimes I may be able to reduce at the end. Never reduce until the end. We're going to write that in. Okay? Never simplify until you are down to 1 fraction. Okay? So I don't want to start canceling a bunch of stuff right away, or at least attempting to, and then finding out, oh, I just made more work for myself. So the easiest way to do it is when you get down to 1 fraction, then we can cancel some stuff, okay? Do some things that way, but we got to simplify first. So the nice thing, though, again, about like denominators, put my parentheses in, I see my pluses there. You're like, okay, well, they're the same, that's good. 2x minus 4, okay. Now here's one suggestion I'm going to make. I notice, okay, well, these aren't the same, but could I factor something up in the numerator? Okay, I can take a 2 out of there. Now, in this particular case, I'm going to take my 2 out. So I'd have 2 times x is 2x. 2 times negative 2. You're like, but Harty, that didn't help me at all, because I still can't cancel the x's because, well, these aren't the same. But it's a good idea to, just because there will be some instances where you're going to be able to cancel something once you factor. And the only way to know if that's true in that problem is to actually try and simplify it a bit. So I'd suggest this. If you got to this, technically that's the right answer, but you don't want to run yourself into a problem. Okay, this is our tricky one. First question. Are my denominators the same? Oh, I'm getting yo and no and yes.
Negative 9 and positive 9.
Okay, let's plug in a number for x and see what happens. So let's say we use 4. So here I'd have 4 squared is be 16 minus 9, and here, so is 16 minus 9 and 9 minus 16 the same thing? No, but there is a way to make them the same. And here's how this works. I can pull a negative out of something. Now, stick with me on this. Okay? If I pull a negative out of here, that changes the signs on both of these values. So my positive 9 would become negative. My negative x squared would become positive. Because I haven't changed the value at all, because negative times negative is positive, and this negative times positive would make that negative. It's the same thing. But what happened was, now my x squareds both are positive. My 9s are both negative. So what I have in the parentheses here and here are now the same thing. You're like, okay, but how do I simplify it now? Because doesn't that negative have to go somewhere? Yes. So here's how we're going to do this. And no, this doesn't happen often, but it does happen sometimes. So we have to be ready for it. That negative, I'm just going to move up into my numerator, because as long as it's somewhere, I can have it. So now that makes my denominators the same, which makes me happy. And the only thing left I have to do is to distribute that negative through and combine my like terms. So I look and I'm like, okay, so that's going to be negative 2. So negative 2 plus 11 is 9. And then the opposite of negative x, or negative times negative, is a positive 1x. So 1x and 2x is 3x. But wait. Am I done? No. So you guys know to answer that question every time I ask it now. Okay, let's see what else we might be able to do here. Simplify, because now we're down to one fraction. So now is when we need to start thinking about this a bit. And if I have to run a little bit down here, we can. 3 does go into both of those. I like it. So 3 plus x. Ooh, but there's even one more thing to look at. Well, let's look at the denominator for the minute. Are they perfect squares? Yes! Okay, so now I'm going to go ahead, I'm going to factor this too. So x times x is x squared. Okay. 3 times 3 is 9, and from my help sheet, I know one's a plus and one's a minus. So my final question then, wow, I don't even have to talk anymore. This is great. I can just run the video. Are we done? No. Okay. Can I cancel anything? Can I cancel the 3's? No. Okay. This one's in parentheses, bonded. This one isn't. So I finally made it to the end. Okay. That is as crazy and nasty as they will get. But again, that doesn't happen often. But again, I'm not going to be the teacher that shows you all the easy ones and then gives you the hard ones and goes, oh, figure it out. So that's not how I work. Okay. Now, the ones we've done so far have basically had a like or a common denominator to start. What happens if they're not? Okay. We're going to have a little process that we're going to run through with this. And I'm even going to have a little cheat sheet for you starting tomorrow that we're going to kind of use as a kind of a segue into the lesson. But for now, here's what we're going to do. We're going to make a little 3-step process up here. Okay, when you have unlike denominators, my first job is if I have coefficients, if I have just plain old numbers down there, I want to find the least common multiple. So like if I had 3 and 4, I got to figure out what's the first number if I listed them off the 3 and 4 are going to have in common. We'll get to that. Okay. So that's my first job every time. My second job, okay, is going to be to look for single exponents. They're not hooked up with a plus or minus. They're not bonded. They're just kind of playing the field here, okay? So in that case, we always want to take the one with the biggest exponent. Now that's different from what we were doing when we were factoring before. We'd always take the smallest one. But when we're finding common denominators, we're always looking for the biggest exponent on a single one to use. And again, we'll see an example of that. And then finally, we need to find every single different set of parentheses that are there, and they all get included. Every single time there's a different one, we got to include it. So that's going to be our 3 steps to build our denominator, and then we're going to have to figure out how that affects my numerator. So this is, this is a process. It is, but it's like everything else. Once you practice it a couple of times, you can start whipping through steps on this. You can even skip some steps. I didn't say that. Okay. I'm just going to bump this a bit because I see some of you are still writing, so I'm not going to go speeding ahead here. Let me just get my parentheses on my denominators because I don't want to mess this up. And like I said, I'm going to run through that checklist on every single one of these. So here's how this works. I'm looking just at the denominators here at the start. I don't care what's going on up top yet. Do I have any numbers hanging out outside the parentheses? No. Okay, we get to skip step 1. Do I have any, variable terms or single exponents sticking out here? No. But do I have sets of parentheses? I do. So, my job, every unique set of parentheses I see, I'm going to write in for my common denominator. So my common denominator for this problem is going to be x minus 5 and x plus 2. Once I get that part set, I got one job left. And here's how that job works. Whatever's already up in the numerator, I'm going to rewrite it. But now I have to become a fraction builder. And here's how fraction building works. Whatever I did to go from my old denominator to my new one, whatever's missing, whatever I'd have to multiply this by to get to this, I have to put up in the numerator as well. So here's how I like to do it. I'll literally go and I'll check off. I'm like, okay, I got the x minus 5 part, but ooh, I don't have this part. Okay, so I got to put that up here. Ooh, but wait, remember, we have to get down to one fraction before we can cancel, so don't start canceling things yet. And we're going to do the same thing here. Whatever I already have the x plus 2 part, but whatever I'd have to multiply to get here, whatever I haven't checked, is what's going to go here. And Michelle brings up a good point. We're so used to at this point saying, ooh, I see the same things here. I'm going to cancel them. Well, here's my problem. If you do that, you're going to end up back at the original problem. That was kind of a waste of time then. So here's what we're going to do instead. We've got to simplify this down to one fraction. So we're going to do some distributing. We're going to clean this up. 2x squared plus 4x. Put my minus in here. Okay, and I'm going to put a set of parentheses. I'll explain why here, why I'm doing it on this one in a sec. 4 times x is 4x. 4 times negative 5 is negative 20, because I'm subtracting that entire second part of my fraction. So this negative's got to go to both of these. Okay, my denominator is not changing anymore. And I got one last step. So those of you that are running out of room, don't worry. This is our last part. Keep that denominator the same. Okay, let's check this out. 2x squared. When I start to distribute through, I'm like 4x. Ooh, but that's minus 4x. So they just cancel. And then a negative 20 gives me plus 20. Now, I'll tell you ahead on this one. This is as far as you're going to be able to get, as far as there's nothing that's going to cancel at this point. Now, you may look at that and go, wait a minute, though. I could take a 2 out of there, right? That's always a good idea if you can take something out to do that. But you'll notice I still don't get to cancel anything, because that's not like a difference of squares or anything. But again, either of these answers would be okay. But it's, again, a process. Now, some of you are like, that is a lot of stuff to have to do for one problem. But as we get better at it, you may be able to go straight from here to here. But otherwise, having to build a fraction this way is not a terrible thing to have to do. And we'll try doing some shortcutting as we go, but we're not going to do it yet because we got to learn some stuff here yet. So we'll see how this goes. Okay. Now, before I start going down my checklist, is there anything that's factorable in the denominator?
4x squared.
Yeah, I can take out a 2x here. And then 2 times 2 is 4. X times x is x squared. I'm just getting this back. And then minus 1, because I have to hold the place. Once you've factored it, I literally go back and scribble that old part out so I don't get confused when I'm trying to build my fractions here in a minute. All right, here's our first fun one to deal with when it comes to the fractions. And I just worked down my checklist. Okay, coefficients. Okay, I got 2 this time, 2 and 6. So if I were to start counting by 2's and 6's, what's the first number that's going to show up in both lists? So if I started counting here, okay, 6 is the first number that's going to show up in each list. So I'm going to use 6. Now, would it be terrible if some of you might have said 12? Would it be awful if I used 12? No, it just means I'm going to have to reduce some at the end. Okay, so we got that part taken care of. Okay, single exponent terms. There's an x squared and there's an x. Which one do I want to use? Wait, back up. Okay, what's that?
Why are you putting a 6 in there?
Because remember, we've got to have a common denominator. So when I'm building that common denominator, and I'm looking at this 6 and this 2, I've got to find some factor that they have that's in common. So if I start counting by each number, that first number I have is going to make it when I build my fractions that I can have that common value. Okay? So when I go to look at my exponents or my single variable terms, I'm going to use the x squared because I want to use the one with the bigger exponent. And then I only have one set of parentheses, the 2x minus 1. That's going to finish off my common denominator. You're like, whew, it's kind of large. So once I have that, okay, we go into builder mode again. Whatever was there to begin with, we go ahead and leave it. And now it turns into our little contest or puzzle, I guess, like we had before. I go from my old to my new. Whatever I've already got, 6x squared. Okay, I got that piece. I don't have the 2x minus 1, so I need that part. Again, no canceling at this point. Now the second part, this gets a little more interesting. Got the 2x minus 1. What do you have to multiply 2 by to get to 6? 3. And x to get to x squared? X. Okay. So every time I do these, my old denominator times whatever I did here should get me this. And again, that's the hardest part of this. If you can get that one part down, you've got this. So let's see what we got working here. Let's see if we can clean this up here. So I got x times 3x is 3x squared. And 5 times 2x is 10x. And 5 times negative 1 is negative 5. And I'm gonna kind of do something nice here. Normally I'd say, well, we got to try and slide and divide this. So I'm going to tell you, it's not going to work when we do it. Okay. That one's done. Because again, remember, these are bonded with plus and minus. I can't cancel the 3's. I can't cancel the x squareds. Bonded, not bonded. Okay? And these aren't the same. So a lot of the time, once you combine, you're going to be done. And I would say if some of you are like, well, how am I going to know? That's going to frustrate me. I'm not going to do it. If that's the case, do this part, combine the like terms, and circle your answer every time. Worst case scenario, you'd miss like 1 point somewhere because you didn't reduce. Yes, I just said that on video. The math teacher said don't worry about it. All right. I'm trying to think where I want to go here. I think I want to go to 6 and then 8. 6, 8, 9. Okay, got it. But again, you've asked some good questions so far. If there is a question as we're going through, please make sure that let me know here what we're thinking. Sure. All right, denominators, factorable. Yes. So let's see. What multiplies to 4 and adds to 4? 2 and 2. Now, here's an exception, okay? Notice I have the same set of parentheses twice in the same denominator. I'm going to rewrite that as x plus 2 squared. I'll explain why here momentarily. And then I have a difference of squares over here. And again, keep referring back to your help sheet. That's a fine thing to do. If you're not remembering something, we can do that. So I get that all cleaned up, even though it doesn't look very clean, but it is. And I look and I go, okay, no coefficients in front, don't worry about that. No single variable terms in front, don't worry about that. Then I get to the parentheses part. And I see an x minus 2. And I see an x plus 2, but here's what's happening here. If you have one term where there's actually more than one, where there's a squared, I've got to use both of them. That's the only time I use both of them. Okay? If this would have just been x plus 2, I'd have used it one time. But if it shows up with a squared, I got to use the squared. So I get that set. I already got my x plus 1 here, and I got my 2 over here. Okay, whatever's there at the start, still got to be there when we're building. And so I start to look now, and I go, okay, old denominator, new denominator. Got the x plus 2 squared already. I didn't check this off. So I got to do that. I come over here. Old to new. I got the x minus 2. I have one of the x plus 2's, but I need 2 of them. I heard that, so we're going to work sideways. Okay. Some of you are looking at this one going, wait, how did you, what? Okay, here's what we're actually doing. Here's my original. Okay, I got to multiply that by something to get to this value on the end. So here's what I look at, and I go, okay, well, I've got the x minus 2. Oops, that's supposed to be minus. I've got this part. If I put an x plus 2 in on both of these, now I've got 2 of these, which takes care of this. Okay. And then now I just have to multiply this across, which will simplify it in a minute. So that's where this is coming from. Some of you may want to look at it, you know, horizontally instead. Maybe you don't like looking at it the way I do, where I'm coming from one spot down to the next, and you want to work right across. You can. Oh, I see. Okay, I see what you're saying. Yeah, a better way of saying that would have been, I'm at x plus 2. I need to be at x plus 2 squared. Ooh, I need to multiply by 1 more to get there. So, okay, if we need to move into 7, we can, because we're going to go to 8 next, and that's probably going to leave us some more room here. So we've got a couple of things we have to play with. They're like, oh, dear. Harty, This is a lot to keep track of. That's why we spend 3 days doing it, because we want to make sure. Here, I need to box or FOIL this out, because I got 2 sets of parentheses. So let's kind of scratch this out of our way. I mean, there are going to be some things that go on in life, especially in math class, that seem kind of tedious. But then when you get to the end and you're like, oh, that's why I had to go through that. Makes a little more sense then. So I get that multiplied out, and I go, okay, so that's going to be x squared minus x minus 2. That's my first fraction. And here's what I'll have people do sometimes so they're not having to redo this a bunch. Sometimes a lot of people, when they see the minus here, they'll say, hey, can I just do this? Can I just be like, this is negative 2 and distribute that through instead? Sure, you can do that. You just want to make sure then I'd make that plus. So minus 2x, negative times positive is negative. And now I just got to clean up the top and I'm going to be done. Combining my like terms to where some of you can see how once I get the hang of this, there's parts I'm going to be able to put together. It's just a big patience game right now. And I'm set. So again, don't worry. No worries. We're going to take a look at 8 and 9, and then I think, yeah, that's as far as I'm going. We'll deal with craziness another time. Okay. So these last couple, so we're going to nail this. Yeah. So again, my first job, look at the denominators. If I can factor them, even if it's just taking out a common term, I do that. But I've got to be able to recognize things like difference of squares. Because if I forget that part, could make my LCD a lot harder than it needs to be. So I get that factored out. And again, when I go looking for my common denominator, I go, okay, any coefficients, any numbers hanging out in the front? No. Okay, didn't have to worry about that. Any single variable terms? Yes, I have an A, so A is part of it. And then every different set of parentheses. Now this is where we're going to make a comparison with what we did in 6 and what we're going to do here. I see an A plus 2. And I see an A minus 2, but I'm not doing A minus 2 squared, okay? The biggest exponent I see on an A minus 2 is 1, so that's all I'm going to use. The reason I use 2 up here is because I actually had a squared on one of them. So I have to look for those little details as I'm doing these. So I get my 10 and my 5 in there, and I go into builder mode. And again, it's about making fractions that are equal. So when I go from here to here, again, I still like checking off the pieces of the puzzle that I have. And then whatever's left, I go ahead. And that's the part I need to put up here. And again, I'm not canceling right away, but here's what you can kind of do mentally. If I were to cancel, check out what I have left. 10 up in the top and A minus 2 in the bottom. So I have equivalent fractions. They just look a little different. And then I do it one more time here. I got the A plus 2. I got the A minus 2. The only part that's missing is the A. So my last step is I kind of go up here diagonally. to work up this way. And I look and I'm like, okay, I got 10a here minus 5a is 5a. 10 times 2 is 20. And yes, just to play it on the safe side, I look at that numerator and I say, hey, I can still take a 5 out of there. So I take my 5 out. 5 times 4 is 20. I don't have any parentheses that cancel. This a is hanging out, but I don't have another a to cancel it with. And I'm set. So again, this recurring theme that we're going to keep seeing throughout these, all the way through, over and over and over again, is factor my denominator. I got to be careful too, because if I factor it wrong, that's I'd be ticked then. Factor it wrong, go through all that work, and then go, crap. I had to go all the way back to the beginning and mess this up. Now the happy thing about doing diamonds on both of them is I don't have any coefficients. I don't have any single variable terms. Okay? So I get to here and I go, okay. Oh dear, I'm writing too big. So I got 3 sets of parentheses this time because x minus 4 and x plus 1 and x minus 2 are all unique, but the largest exponent on them is 1. Don't square the x plus 1. Don't do it, don't do it, don't do it. So once I get here, again, builder mode. How do I get from the old denominator to the new one? Whatever pieces of the puzzle I already have, I don't need to put them in. Whatever I don't check off gets included. So it's like new and improved numerator. And now it's just going to be a little bit of cleanup, and I'm going to be ready. But you probably can notice all the way through these, the only time anything canceled was way back up on number 3. So more times than not, once you clean this up, you're going to be safe anyway. So I look and I'm like, okay, so this is going to be 5x minus 10 when I simplify it. And if I put that negative here, that'll be negative 3x plus 12. It can save you a step by just kind of doing a little side work on that. 5 minus 3 is 2. Negative 10 plus 12. Of course, this is going to happen when I just said that. Is positive 2. Does this simplify? I can take a 2 out. Okay. Now let's see what that does. Finally, we get to do something, air quotes, fun. Because I went ahead and I factored that. I do have a common set this time. So my final answer now, I am on a happy note, not that this is the longest assignment in the history of man, but I am actually going to do a little bit of trimming. And I'm actually putting this on video so I don't forget either. We are going to whack 27 and 29 off of this for right now. So let me come back up here for a minute. So the whopping 8 problems, 2, 4, oh yeah. Okay. And tomorrow we'll be worksheeting this again and going through it. I'm going to give you a cheat sheet that we're going to work through together to kind of help you doing some of this stuff. So when you do get to a quiz on this, you're going to have another good tool to be able to use.